Hey guys, in this video we're going to be talking about parallel and perpendicular lines. So if you haven't checked out my videos yet on how to find the gradient of a straight line or how to find the equations of straight lines, do go back and check them out, make sure you're proper happy with them. So in the finding equations of straight lines video, I did talk about parallel lines quite a bit, but there is a little bit more here that I want to cover. This video is aimed at the higher minions. Obviously that video was for foundation and higher, so there is a little bit more on parallel lines that I want to say, but the main study in this video is going to be on perpendicular lines. Okay, so let's get cracking. Okay, so a little bit of revision to kick off with. Remember, the general equation of a straight line is going to be our best friend when we're playing with this video. Y is equal to mx plus c, where m is the gradient of the straight line and c is the point where it cuts the y-axis, called the y-intercept. Now, lines always need to be in this form for us to be able to read off the gradient and the y-intercept. It's no good if we've got something multiplying y, or if the x term is on the same side as the y. The y needs to be on its own on one side of the equation. It needs to be the subject of the formula. So that's really where we're going to go into a bit more detail with the parallel lines, because I didn't mention that in the equations of straight lines video. So remember then that if two lines, or any amount of lines, if lines are parallel, then it means they have exactly the same gradient. So it means that m is the same in all of their equations. So here we have three lines plotted. We've got y equals 2x plus 5, we've got y equals 2x, and we've got y equals 2x minus 3. Now all three of them have got the same gradient. The m is the same in each equation, the number multiplying the x. They all have the same gradient, therefore they are parallel. Now remember, when lines are parallel, they never ever meet. Never. Can't happen. Okay. So let's run through these examples here then. So give examples of lines parallel to. So first of all, y equals minus 5x plus 9. Well, we need to find the gradient. That's nice. That's minus 5. So it's important to remember that any line has an infinite number of parallel lines. We could simply have y equals minus 5x. That's parallel. It's got a gradient of minus 5. We could have y equals minus 5x minus 1,000. So both of those are examples of lines parallel to y equals minus 5x plus 9. Remember, the number at the end, the y-intercept, has absolutely nothing to do with the slope of the equation of the line. It is literally just the m part that we're worried about. So any equation with a minus 5x in it is going to be parallel to y equals minus 5x plus 9. Cool. Okay, y equals x over 2 plus 6. Now x over 2 is technically saying 1/2 times x. So here we would want then any equation with a half x. So we could have y equals x over 2 plus 100. Definitely parallel. We could have y equals just x over 2 itself. That's also parallel because they've both got a gradient of a half, the same as y equals x over 2 plus 6. Okay, what happens then on these bottom two examples here? So as I said before, to be able to read off the gradient and a y-intercept, we need to have y as the subject of the equation. So at the moment we've got 3y minus 2x equals 4. So before we can read off the gradient and the y-intercept, if we wanted to, we need to do a bit of algebra jiggery pokey to get y on its own. So if we first of all add the 2x, we get 3y equals 2x, add 4, and then we need to divide by that 3 on the y. Now we would get y equals 2x over 3 add 4 over 3. We could write that as a single fraction. We could write it as 2x plus 4 all over 3, or we can indeed split it up like that, which I have done here to hopefully make it clearer now that our gradient is 2/3. So if we want parallel lines to y equals 2/3 x at 4/3, then we just need to have a 2/3 x. So we could have y equals 2/3 x minus 1/3. That would be parallel. We could have y equals 2/3 x add 1,000,000 if we wanted to. And that would be parallel because we have got the 2/3 x as we need. Cracking. Again, in this final example here, 10x minus 3y equals 1. So this time we've got a minus 3y on the left. So I would add that to both sides. So we would get 10x equals 3y plus 1. Then take away the 1. We get 10x minus 1 is equal to 3y. And then divide by the 3. We would get 10x over 3 minus 1 over 3 is equal to y. Now it does not matter at all that y is on the right hand side instead of the left hand side. That really doesn't matter at all. If it really bothers you, you can just swap sides, put the y on the left and put the other stuff on the right. You're absolutely fine to do that. But we have got what we need. We have got y on its own on one side of the equation. So we can now read that the gradient is 10/3. So any parallel line to this bad boy is going to have something to do with 10/3 x. So even y equals 10/3 x would do the job absolutely fine. Or we could even have y equals 10/3 x minus 2. That would work. Anything starting with y equals 10/3 x is going to do that job just fine. Cracking. Okay then, on to perpendicular lines. So what does perpendicular mean? Things are perpendicular when they meet at right angles, or 90 degrees. So if two lines are perpendicular, it means that they intersect at a single point, and that point will be a right angle. So when two lines are perpendicular, and this is the most important point to take away from this video, when two lines are perpendicular, their gradients multiply together to give -1. So if we take the gradient of our first line, and we just call it M1, and the gradient of our second line, we'll call him M2, then if we multiply M1 by M2, we get -1. Okay, that's really, really important. Get that down. Okay, so then down here on the right, I've given us a little example of two lines that are perpendicular to another line. So here we can see we've got this line going up from left to right, and then we've got these two other lines that are going down from left to right. Now these two lines are in fact parallel to each other. Each of them though is also perpendicular to the line that is going up from left to right. So that's what it looks like when two perpendicular lines meet. Or in fact we've got two examples there of two perpendicular lines meeting. So that's what it looks like on a graph. But again, the lines meet at right angles. Okay, let's get down to business. Okay, so first of all, what we're going to do, we're only going to be worrying about gradients. So here I've given us 6 examples of our first gradient, and we're going to want to work out the perpendicular gradient. Now, before we get cracking, there's something that's going to make this job a lot easier. Remember from the last page that I said M1 times M2 equals -1? Well, if we're given a gradient and we want to work out the perpendicular gradient to it, how do we do that? Well, we need to make M2 the subject of that formula there. So if we've got m1 times m2 equals -1, we would get rid of m1 by dividing it. And that would leave us with m2, the second gradient, equals -1 divided by m1. So for these 6, we've been given m1, we need to find m2, so we simply divide -1 by the gradient we're given. So for m1, here being 3, m2 is going to equal -1 over 3, minus a third. Cracking. The second one, m1 is 1, well, m2 there is just going to equal -1 divided by 1, which is just going to give us -1. The third one, m1 equals -5. Okay, be careful when negatives get involved. m2 then will be -1 divided by -5. Now a negative divided by a negative gives you a positive, so that's actually going to be positive 1/5. m1 equals a half. Well, m2 is going to equal, now that's going to be 1 divided by a half. Now remember, if you are dividing by a fraction, you flip it over and multiply by it. So 1 divided by a half is equal to 1 times 2 over 1, which is just going to give us 2. But remember, that's going to be -2, because we do -1 divided by the original gradient. So if our gradient is a half, the perpendicular gradient is -2. Okay, m1 equals 3 halves. Well, m2 then will equal -1 divided by 3 halves. Now that's equal to -1 times 2 thirds. Now if we do -1 times 2 thirds, the -1 just multiplies the 2 on top, and we get -2 thirds. Cracking. And then the sixth one, m1 is -4 thirds. Well, m2 then is going to be -1 divided by -4 thirds, which would become -1 times. Now, this is going to, when we flip -4 thirds over, it's going to give us -3/4. So we've got -1 times -3/4, that gives us +3/4. So the perpendicular gradient to -4 thirds is +3/4. Okay, so that's how we find perpendicular gradients. Let's have a look at some trickier questions. Okay, are y plus 3x equals 1 and y equals x minus 10 all over 3 perpendicular? Well, how do we know that? We need to find what each of their gradients are first of all. So, if we got y plus 3x equals 1, we need to get y on its own, and we would do that by taking away the 3x. So we would get y equals -3x plus 1. So y plus 3x equals 1 has a gradient of -3. Now, what can we do with this second equation? Well, if you have a fraction like this, you've got 2 or more terms up on top, you can split it up. So we could say that this second equation can also be written as y equals x over 3 minus 10 over 3. So x over 3 is telling us that's exactly the same as 1/3 x. So the gradient of this second guy is 1/3. Now let's write down what we've got. The gradient of the first line, m1, is -3. The gradient of the second line is 1/3. Let's see what happens when we multiply those. -3 times 1/3 gives us -3 over +3, which does indeed give us -1. So yes, the two lines are perpendicular because they're two gradients multiplied together to give us -1. Job's a good one. Okay, a line perpendicular to y equals x over 5 add 3 passes through the point 1, 3. What is its equation? Okay, so here then, we know the gradient of a line. We don't care about the plus 3, we only care about the gradient. So, m1 is equal to x over 5, well that tells us that the gradient is 1/5. So, m2, our second gradient, our perpendicular gradient, is minus 1 divided by 1/5, which is the same as minus 1 times 5, which gives us minus 5. So the gradient of our perpendicular line is minus 5. So we can start filling in the gaps on y equals mx plus c. We now know that y equals minus 5x plus c. So now we need to work out the y-intercept. Now remember, to do that, we use the coordinates that we're given. So we're told that this perpendicular line passes through the point 1, 3. Now remember, coordinates are telling us when x is equal to this certain number, y is equal to this other number. So here, when x is equal to 1, y is equal to 3. So we substitute those in to the equation. So y is now 3, x is 1, minus 5 times 1 is minus 5, plus c. Now if we add the 5 to both sides, we get 3 plus 5, which is 8. And that's our value of c. So, the equation of our perpendicular line here is y equals minus 5x plus 8. Job's a good one. Cracking. Okay then, the final example for this video. Line A passes through P, 1, 2 and Q, 5, 10. Line B is perpendicular to A and passes through point P. Find the equation of line B. Okay, so this is probably quite a tricky one. Definitely quite a tricky one. We're not told the equation of the first line to start with. We don't need the equation of the first line though. All that we need to know is the gradient of the first line. So we know the 2 points, or we know of 2 points that line A passes through. That's all we need to be able to work out the gradient. We could go all the way, we could find the equation. We don't need to, so we're not going to. Okay, so to find the gradient of A then, let's call it M1. Remember that to find the gradient, when you've got 2 coordinate points, you find the difference in y. So here I'm going to do 10, take away 2, divided by the difference in x. So 5 take away 1. Now 10 take away 2 is 8. 5 take away 1 is 4. So 8 divided by 4 is 2. So M1 here then is equal to 2. Now, as I said, we don't need to go all the way and work out the equation of line A. All that we need is its gradient. So, now that we know that, we can find the gradient of line B. So M2, sorry, not sure what's going on with the right in there. Even worse than usual, really. There we go. That'll do. So M2 here then, the perpendicular gradient, we know that's going to be 1 minus 1 divided by M1. So minus 1 divided by 2, minus a half. Cracking. So now we know that the equation of our perpendicular line is something to do with y equals, now I'm just going to write that as minus x over 2. That's exactly the same as minus a half x, and then plus c. Okay, so we've done half the work here really. Now the other thing that we know about Mr. Perpendicular Line is that he passes through point P. Now point P has coordinates 1, 2. So when x is 1, y is equal to 2. So we substitute those values in to help us find the value of c. So y is equal to 2. So we get 2 is equal to, now x is equal to 1. So we just get minus 1/2 plus c. So to work out what c is, we need to get rid of that minus 1/2. Now if we were to do that, we would add it. Ideally though, we would want 2 to be in the form of halves as well. Imagine if you have one whole pizza, you've got 2 halves of a pizza. If you've got 2 whole pizzas, you've got 4 halves of a pizza. So on the left, the 2 is the same as 4 halves. So if we add the 1/2, then we get 5 halves is equal to c. So we're almost there. We now just need to write out the equation. So we now know Mr. Perpendicular line, line B. We know the gradient is minus 1/2. So we get y is equal to minus x over 2, or minus 1/2 x, does not matter how you write it. And then plus the y-intercept, c, 5 halves. So line B's equation is y equals minus x over 2, add 5 over 2. Okay guys, that's perpendicular lines. It's a nice little run into finding equations of tangents. Really fun questions. Okay, hope it's helped. Was this video helpful? If so, don't forget to hit the thumbs up button and leave me a comment letting me know how you get on. Also, don't forget to subscribe to the channel so you never miss any videos. For any further information, you can find me on Facebook or Twitter. Search for Maths with Melv. Cheers guys.